welcome back. I'm glad you've returned to the silence. We leave the familiar behind to witness the silent beauty of the cosmos as we begin our long, drifting journey toward Planet 9, the mathematical ghost that haunts the edge of our solar system. Beyond the icy orbit of Pluto, where the warmth of our sun is nothing more than a bright, distant needlepoint of light, lies a realm of absolute shadow and profound stillness. For centuries, humanity believed the solar system ended in a neat, predictable boundary. Yet the deep universe always hides its greatest secrets just past the horizon of what we can readily see. We are drifting now into the great unknown, guided not by the glow of starlight on a metallic surface, but by the invisible, elegant pulling of gravity itself. It is a strange and beautiful realization that an object 10 times more massive than our Earth could be hiding in plain sight, pulling on the fabric of space and shaping the destinies of distant ice worlds. As we venture further into this dark expanse, we must clear our minds of everything we thought we knew about our stellar home and prepare to look at the invisible canvas of the cosmos. To understand this cosmic mystery, we must look at the strange choreography of the most distant wanderers in our neighborhood, the icy bodies that circle the sun in incredibly elongated paths. Astronomers noticed that these outermost worlds do not move at random, but rather their orbits all tilt in the exact same direction and cluster together in space, as if guided by an unseen hand. Why would these lonely blocks of ice, billions of miles away from the inner planets, march to the same rhythmic beat? The mathematical probability of this alignment happening by pure chance is incredibly small, less than a fraction of a percent, which forces us to look for a grand architect. Science teaches us that when the cosmos shows us a pattern so precise, it is never an accident, but rather a signature left behind by a massive, hidden presence. This unseen master of gravity is what we call Planet 9, a world we have never photographed, yet one whose existence is written clearly in the mathematical laws of nature. There is a profound poetry in discovering a world through math before our eyes ever glimpse its physical form, a testament to the power of human thought reaching out into the dark. We cannot see it because it resides so far away that sunlight takes almost a full day to reach its surface and bounce back to our telescopes, fading into nothingness along the way. Yet, gravity requires no light to travel, and it binds this giant planet to our sun in a slow, majestic dance that takes 20,000 years to complete a single circle. We must wonder what such a world looks like, wrapped in an atmosphere of hydrogen and helium, freezing in the eternal twilight of interstellar space. Is it a captured runaway from another star system? Or did it form close to our sun, only to be violently hurled into the abyss during the chaotic infancy of our planetary family? As we ponder these deep questions, we realize that the hunt for this ghost planet is actually a search for our own origins, a way to understand the violent and beautiful history that shaped the very ground beneath our feet. The math does not lie, and as we look deeper into the equations, the outline of this giant companion becomes clearer, inviting us to look past the darkness and into the truth of its silent domain. We begin our deep investigation by looking closely at the lonely, frozen worlds that dwell in the outermost fringes of our solar system, far beyond the reach of the giant planets we know. These distant wanderers, moving through the freezing dark, follow paths that are strangely elongated, stretching out like massive ovals into the interstellar void. Scientists refer to these cold travelers as extreme trans-Neptunian objects because their entire lives are spent in the deep shadows, well past past the orbit of blue Neptune. As we map their journeys, we notice that they seem to ignore the gravitational rules established by the inner planets, tracing their own unique lines across the dark fabric of space. It is within these mysterious, elongated paths that the first subtle whispers of a much larger, hidden presence began to reveal themselves to patient observers on Earth. The unexpected shape of their tracks hints at an untold story waiting to be uncovered in the deep silence. When we look at the points where these distant icy worlds make their closest approach to our sun, a stunning pattern emerges from the mathematical data. Instead of being scattered randomly in every direction like seeds thrown into the wind, their closest orbital points all cluster together in the exact same region of space. Imagine a vast celestial clock where all the hands mysteriously point toward the same hour, despite having entirely different lengths and speeds. This strange physical clustering tells us that a powerful force is actively organizing their journeys, gently nudging them into a collective alignment. We are left to wonder what immense anchor could hold these wild wanderers so perfectly in place across such vast distances of empty space. The alignment is too perfect to be an accident, suggesting a silent guardian is constantly maintaining this order. The mystery deepens when we examine the actual tilt of these orbits relative to the flat plane where Earth and the other familiar planets reside. These outermost icy worlds do not share our common planetary floor, but instead, their paths are tilted upward at almost identical angles, cutting through space like a fan left slightly open. This shared inclination means that whatever is influencing them is not just pulling them sideways, but is also lifting them out of the main planetary disk. A massive object must be sitting at a specific angle in the dark, using its gravity to tilt the paths of these smaller bodies over billions of years. By studying the precise degree of this tilt, mathematicians can begin to sketch the unseen orientation of our solar system's ghost companion. Every angle we measure becomes a brushstroke in a portrait of a planet we cannot see. To understand why this alignment is so profound, we must look at the mathematical laws of probability that govern the universe. If there were no heavy object hidden in the dark, the chance of these independent worlds aligning so perfectly by pure coincidence would be less than 1 in 10,000. It is mathematically nearly impossible for such a precise pattern to exist without a physical cause directing the motion of these frozen travelers. This tiny probability acts as a glowing beacon for scientists, proving that we are not looking at a random cosmic accident, but rather at a highly structured system. The math demands an answer, forcing us to accept that an unseen giant is actively sculpting the architecture of the outer solar system. It is the quiet certainty of numbers that guides us through the darkness of the unknown. The mathematical models reveal an even more beautiful secret about how this hidden planet interacts with its smaller, icy neighbors. Computer simulations show that Planet 9 must follow an anti-lined orbit, meaning its own elongated path points in the exact opposite direction of the objects it shepherds. As these small ice worlds rush inward toward the sun, the giant planet is moving away into the deepest part of its own distant loop. This cosmic configuration creates a delicate gravitational balance, allowing the smaller objects to avoid colliding with the giant while still feeling its constant, steady pull. It is a grand celestial dance of avoidance and attraction, where the unseen partner guides the steps from the opposite side of the dark stage. Through this anti-alignment, the stability of the entire region is preserved over eons of time. Through the elegant equations of gravity, scientists have been able to calculate the approximate weight of this mysterious world without ever catching a glimpse of its surface. The mathematics suggest that this ghost planet is a true heavyweight, possessing a mass roughly 5 to 10 times greater than our own Earth. An object of this size would likely be a mini Neptune, a world wrapped in a thick, frigid blanket of gas over a heavy rock and ice core. It is the missing link in our solar system's planetary family, occupying a mass category that is incredibly common around other stars, but strangely absent from our own known neighborhood. The sheer weight of this entity explains how it can command the motions of so many distant worlds from such an immense distance. Its invisible presence carries a heavy signature that cannot be erased from the cosmic record. The true scale of this cosmic hunt becomes apparent when we calculate just how far this hidden giant must be from the warm embrace of our sun. The mathematical models place Planet 9 at a distance that is hundreds of times farther from the sun than our own planet Earth. At its most distant point, it drifts nearly 20 times farther out than Neptune, entering a lonely realm where the sun appears as nothing more than an exceptionally bright star. In this silent world, the gravitational grip of our star is incredibly weak. Yet it is just strong enough to keep this giant companion bound to our solar system. The vastness of this distance means that a single year on this planet lasts for thousands of human generations, a slow and silent passage of time. It exists in a state of eternal isolation, charting a path through the quietest corners of space. We must ask ourselves how these fragile icy objects have managed to survive on their eccentric paths for billions of years without being scattered into interstellar space. The answer lies in a beautiful mathematical phenomenon known as orbital resonance, where the paths of the objects lock into a stable harmony with the giant planet. As the smaller bodies complete their journeys, their orbital periods match up in perfect mathematical ratios with the orbit of Planet 9. This resonance creates a protective gravitational shield, ensuring that the small worlds are always pushed back into their stable tracks whenever they begin to drift. It is a self-correcting cosmic mechanism, an invisible framework that has maintained the order of the outer solar system since the very dawn of creation. This enduring harmony proves that the system is not chaotic, but beautifully organized. Before accepting the existence of a single massive planet, astronomers carefully considered whether a massive ring of smaller icy rocks could produce the same gravitational effect. They calculated the total amount of mass left over from the formation of the solar system to see if a collective belt of debris could hold these orbits together. However, the mathematics quickly revealed that the entire Kuiper Belt combined does not possess anywhere near enough mass to cause such a dramatic alignment. There is simply not enough scattered material in the outer dark to act as the architect of these tilted and elongated paths. This mathematical elimination of other possibilities leaves us with only one logical conclusion, pointing directly to a single, concentrated mass lurking in the shadows. The ghost planet remains the only explanation that withstands the rigorous test of physical laws. The ultimate test of any scientific theory is its ability to predict new discoveries that have not yet been observed by human eyes. When the mathematical model of Planet 9 was first created, it did not just explain the paths of the objects we already knew, but it also predicted that we would find new worlds with even stranger orbits. Specifically, the math showed that the giant planet's gravity should push certain ice worlds into paths that run completely perpendicular to the rest of the solar system. Amazingly, when astronomers looked through their telescopes, they discovered several highly inclined objects exactly where the mathematical equations said they should be. This incredible confirmation proves that the model is not just a clever guess, but a highly accurate map of a reality we are still waiting to see. The math has shown us the way, and the universe is slowly revealing the truths hidden within those equations. To appreciate how this incredible narrative came to light, we must trace our steps back to the dedicated researchers who first dared to put these mathematical pieces together into a unified theory. In the early months of 2016, two planetary scientists working at the California Institute of Technology changed our view of the outer solar system forever by publishing their groundbreaking model. Initially, they set out to disprove the strange orbital alignments, thinking that some observational error or bias had tricked earlier astronomers into seeing a pattern that was not truly there. Yet, the deeper they drove their mathematical calculations, the more they realized that the anomaly was completely real and could not be swept away. Their journey transformed from one of deep skepticism into a profound realization that a massive, dark world was the only logical anchor for these wandering ice bodies. This shift from doubt to certainty marked the true beginning of the modern hunt for our solar system's hidden ghost. The long trail of clues actually began more than a decade before that announcement, with the discovery of a highly unusual and lonely world known to science as Sedna. Found drifting in the frozen deep in 2003. This reddish world presented a massive puzzle to astronomers because its orbit never brings it anywhere near the major planets. Even at its closest approach to our Sun, Sedna remains far beyond the gravitational reach of giant Neptune, meaning that Neptune could not have put it into such a wild, elongated path. This isolation forced scientists to look far out into the dark for an explanation, realizing that some other massive body must have pulled Sedna outward during its long history. Sedna became the first recognized member of a completely new class of detached objects, serving as a lonely pioneer that pointed the way toward a hidden giant. It was a silent witness to a cosmic force that humans had not yet identified or understood. For many years, Sedna stood completely alone as an inexplicable anomaly, until another distant wanderer was detected in the deep shadows of the outer solar system. This new object, officially designated as 2012 VP-113, matched Sedna's strange behavior almost perfectly, sharing a similarly detached and highly elongated path. When astronomers realized that this second ice world also made its closest approach far beyond the influence of Neptune, the mystery transformed into a clear and undeniable pattern. The discovery proved that Sedna was not a solitary cosmic accident, but rather part of a larger family of objects moving under the same invisible rule. Scientists began to realize that an immense gravitational tide was flowing through this dark region, sweeping these distant worlds into a shared orbital alignment. Each new object discovered in this remote territory added another heavy layer of evidence to the growing mathematical case for Planet 9. To truly understand the significance of these discoveries, we must explore the fascinating concept of detached objects and why they trouble modern planetary science so deeply. In a normal solar system, small icy bodies are constantly scattered and pushed around by the massive gravitational fields of giant gas planets like Jupiter and Neptune. However, a detached object is completely immune to this interplanetary bullying because its path is entirely separated from the space where those giants reside. Because Neptune cannot touch them, some other massive entity must have intervened to lift their orbits away from the main planetary disk and keep them suspended in the outer dark. This separation acts like a celestial fossil record, preserving the gravitational footprints of whatever giant object interacts with them out in the silent void. By studying these detached paths, we are looking directly at the historical signature of an unseen architect working at the very edge of our solar system. The realization that a hidden world might exist required the use of immense computational power to simulate the complex history of our cosmic neighborhood over billions of years. astronomers built highly advanced digital models of the solar system, introducing a hypothetical giant planet into the outer dark to see how it would affect the surrounding space. They ran these supercomputer simulations across vast spans of virtual time, watching how thousands of smaller icy bodies responded to the gravity of this new companion. Remarkably, the digital worlds began to mimic the real universe perfectly, clustering together and tilting into the exact shapes we observe in our telescopes today. These simulations gave scientists a powerful window into the unseen, demonstrating that the presence of Planet 9 perfectly reproduces the strange order of the outer solar system. The numbers flowing through these machines confirmed that theory and reality were aligned in a beautiful, harmonious truth. It is vital to separate this rigorous modern scientific pursuit from the older, imaginative myths of a hidden world, often referred to in the past as Planet X. For over a century, early astronomers searched for a ninth planet based on incorrect measurements of Neptune's orbit, leading to many false alarms and unscientific speculations. The modern hunt for Planet 9 is entirely different because it relies on the hard, unyielding physics of celestial mechanics and the precise tracking of distant icy worlds. We are no longer guessing based on shaky observations of the inner planets, but rather decoding a clear mathematical signature left in the deep Kuiper Belt. This scientific evolution has elevated the search from a romantic mystery into a precise quest guided by the laws of gravity and advanced mathematics. The ghost we are chasing today is built on a foundation of pure data and verifiable orbital dynamics. One of the most complex mechanisms explored by these mathematical models is a phenomenon known as apsidal precession, which describes how orbits slowly rotate in space over immense periods of time. Left to themselves, the elongated paths of these distant ice worlds would naturally twist and scatter in different directions over hundreds of millions of years, destroying any initial alignment. The fact that we still see them clustered together today means that a powerful force is actively fighting this natural scattering, locking them into their shared orientation. Planet 9 accomplishes this by exerting a constant, gentle gravitational torque that counteracts the natural twisting of their paths, keeping them perfectly synchronized. It acts like a cosmic sheepdog, constantly nudging the straying paths back into the flock, so that the beautiful alignment never fades into chaos. This ongoing maintenance proves that the unseen giant is not a temporary visitor, but a permanent resident of the outer dark. The existence of such a massive world so far from the sun forces us to look back at the chaotic infancy of our solar system to understand how it arrived there. During the early phases of planetary formation, the giant gas planets were much closer together, engaged in a violent gravitational tug of war that reshaped their orbits. In this chaotic environment, a young core of rock and ice could easily have been thrown outward by the immense gravity of Jupiter or Saturn, hurled like a stone from a slingshot into the deep void. As this runaway world drifted into the outer darkness, the surrounding gas disk or nearby stars in the sun's birth cluster could have slowed it down, trapping it in its current distant orbit. This means Planet 9 might be a beautiful relic of our solar system's violent birth, a forgotten sibling that was cast out into the cold while the other planets found stability near the sun. We must ask ourselves why such a massive planet remains so difficult to spot with our most advanced modern telescopes if we know its approximate mass and orbit. The answer lies in the staggering vastness of the search area, which covers a massive strip of the night sky that takes years of careful observation to fully survey. Because the planet moves so slowly along its distant path, it appears almost completely stationary against the background of distant stars, making it incredibly hard to distinguish from common stellar bodies. Furthermore, because it is so far away, it reflects an incredibly tiny amount of light, appearing millions of times fainter than the stars we can easily see with the naked eye. Looking for it is comparable to searching for a single black marble hidden somewhere in a vast, dark stadium using only a narrow flashlight. Yet astronomers remain undeterred, systematically scanning the sky with the quiet confidence that the mathematical map will eventually lead them directly to the prize. This ongoing quest is driving human technology to its absolute limits, inspiring the creation of the most advanced sky surveys ever attempted in our history. New observatories equipped with massive mirrors and ultra-sensitive cameras are currently being prepared to scan the deepest recesses of the southern sky with unprecedented precision. These advanced facilities will be capable of detecting objects that are far fainter and more distant than anything we have ever seen before, peeling back the layers of darkness that shroud the outer solar system. Scientists expect that these surveys will either catch the faint reflection of Planet 9 itself or discover dozens of new small worlds that will refine our mathematical models even further. As these powerful eyes open to the universe, we stand on the precipice of a monumental discovery that will rewrite our astronomy textbooks forever. The silent hunt continues, moving steadily out of the realm of mathematical prediction and closer to the bright light of direct human observation. Let us look closer at the central anchor of our cosmic neighborhood, the sun itself, which holds a subtle mystery that can be explained by the presence of this distant giant. For centuries, astronomers wondered why the axis of the sun's rotation is tilted by roughly 6 degrees compared to the flat plane where the major planets travel. In a perfectly orderly system, the sun should spin exactly perpendicular to the disk of material that formed its planets. yet it appears slightly off balance. Mathematical models show that the long, heavy pull of Planet 9, acting over billions of years, would slowly warp the entire planetary plane of our solar system. This constant gravitational tug would make the orbits of the known planets wobble, creating the illusion that the sun is tilted when it is actually our own floor that has been slightly shifted. Through this elegant realization, the ghost planet explains an ancient mystery right at the heart of our solar system, leaving its signature on the very star we orbit. To truly grasp the invisible mechanics at play in these remote regions, we must explore a beautiful gravitational phenomenon known to physicists as the Kozyliov mechanism. This delicate interaction occurs when a large, distant world slowly exchanges its orbital shape and tilt with much smaller bodies over millions of years. Under the steady influence of Planet 9, a small ice world finds its orbit constantly transforming, shifting between a highly flattened oval and a steeply tilted circle. When the path becomes less elongated, it tilts higher into the dark sky. And when the tilt decreases, the path stretches further out into the void. This continuous trading of properties acts like a cosmic pendulum, keeping the small objects trapped in a safe, predictable loop that prevents them from escaping into the interstellar wilderness. It reveals a hidden architecture where shapes change, but the overall structural balance remains perfectly preserved. The strength of these mathematical predictions was beautifully demonstrated by the discovery of an exceptional object found drifting at the very edge of the sun's influence. Discovered in the month of October during the year 2015, this small, icy world was affectionately nicknamed the Goblin by the astronomers who tracked its faint glow. This distant wanderer moves on an incredibly stretched path that takes it even further into the unknown than Sedna, making a single journey around the sun last for thousands of years. When scientists mapped its path, they found that it aligned perfectly with the group of objects that first pointed toward the existence of Planet 9. The fact that this newly discovered world followed the exact pattern predicted by the mathematics provided powerful confirmation that the hidden planet was not a temporary illusion. The Goblin emerged from the deep dark like a quiet messenger, verifying that the trail we are following is real. This brings us to a fascinating realization about the true boundary of our solar system and how we define the edge of our celestial home. Beyond the traditional Kuiper Belt lies a transitional territory known as the Inner Oort Cloud, a quiet zone where stars and our sun compete for gravitational dominance. Objects residing in this remote area should theoretically be easily scattered by the passing gravity of neighboring stars in our galactic neighborhood. However, the worlds we have found there remain firmly anchored, moving in stable paths that refuse to dissolve into the greater galaxy. This unexpected stability suggests that Planet 9 acts as a protective wall, Its massive gravity shielding these inner Oort cloud objects from outside galactic disturbances. It creates a defined perimeter, keeping these ancient ice relics safely within the family of the Sun, while everything else drifts away. While the effects of this ghost world are most obvious in the paths of distant ice objects, its immense mass also leaves a microscopic impression on the giant planets we know so well. Scientists have carefully analyzed the highly precise tracking data collected by the Cassini spacecraft during its long mission around the ringed planet Saturn. Because gravity operates across all distances, the weight of Planet 9 should cause a very tiny, subtle wobble in the orbits of the inner gas giants over long periods. Although this deviation is so incredibly small that it cannot be detected by ordinary instruments, the mathematical equations allow us to place strict boundaries on where the planet can hide. The lack of a major disruption in Saturn's path tells us exactly how far away the hidden giant must be, and helps us narrow down its position in the sky. It is a beautiful example of how a spacecraft orbiting a known planet can help us map the location of a world that is completely invisible. To understand how a planet so far away can dictate the motions of other bodies, we must look at the difference between sudden gravitational encounters and long-term secular interactions. In the inner solar system, planets affect one another through quick, dramatic passes that can violently alter a path in a short amount of time. In the deep dark where Planet 9 resides, the interactions are completely different, taking place through a slow, smooth spreading of gravitational force over millions of years. Mathematically, it is as if the mass of the hidden planet is smeared out into a massive, invisible ring that exerts a gentle, continuous pressure on everything inside it. This steady, non-violent molding of space is what creates the perfect alignment of the distant ice worlds without ever causing a chaotic collision. It is a slow-motion symphony of gravity, where the music unfolds over spans of time that dwarf the entirety of human existence. Another profound clue supporting the existence of this hidden giant can be found in a strange structural feature of the outer solar system, known as the Kuiper Cliff. For a long time, astronomers expected the ring of icy debris past Neptune to gradually thin out and fade away into the deep interstellar void. Instead, observations revealed a sudden, sharp drop-off in the number of small objects at a specific distance from the Sun, as if a cosmic broom had swept the area completely clean. This abrupt boundary is highly unusual for a natural disk of debris, and strongly suggests that a massive object is actively clearing the path. Planet 9's wide orbit would naturally carve out the outer edge of this icy ring, consuming or scattering any small bodies that dare to drift too close to its domain. The cliff is a physical scar in the distribution of matter, a clear boundary line drawn by the gravitational hand of our solar system's ghost. The nature of Planet Nine's own path through space is one of the most intriguing aspects of this entire mathematical investigation. Unlike the familiar planets, which move in nearly perfect circles around the Sun, this hidden world travels along a highly stretched and eccentric path. This means that its distance from the central star changes dramatically throughout its immense year, bringing it relatively closer before hurling it back out to the very edge of the Sun's grip. This extreme eccentricity is reminiscent of a giant comet rather than a traditional planet, making its lifestyle completely unique within our solar system. Traveling along such a stretched path means the planet spends the vast majority of its time moving at its slowest speed at the farthest point of its loop. This slow, frozen lingering in the deepest part of the shadow explains why it remains so elusive to our searching eyes. At the farthest point of its lonely journey, Planet Nine reaches a distance where it begins to feel the subtle gravitational pull of the entire Milky Way galaxy. These galactic tides, generated by the combined mass of billions of distant stars and dark matter, exert a gentle squeezing effect on the outermost edges of our solar system. The hidden giant stands at the crossroads of these two immense forces, caught in a delicate balance between the grip of our Sun and the pull of the wider galaxy. This unique position means that Planet Nine is not just an island unto itself, but a bridge connecting our solar system to the grander galactic environment. By studying how its orbit remains stable under these competing forces, mathematicians can learn about the local density of our galaxy and the history of stars that have passed near us in the ancient past. It transforms the planet from a local mystery into a key that unlocks the secrets of our wider stellar neighborhood. Finally, we must marvel at how the mathematical model explains the existence of a rare group of objects that travel on paths completely perpendicular to the rest of the planets. These unusual worlds do not orbit in the flat disk or even at a slight tilt, but instead, they plunge straight up and down through the solar system like a Ferris wheel. Without the presence of Planet Nine, such extreme paths would be highly unstable, causing the objects to quickly crash into the Sun or be ejected into the void. The hidden planet provides the exact gravitational framework needed to sustain these wild vertical loops, holding them in a stable configuration over billions of years. Seeing these perpendicular travelers moving safely through space is perhaps the most striking proof that the model is correct. It shows us that what appears to be absolute chaos is actually a highly organized part of a grander, hidden design. When we contemplate the visual nature of this elusive giant, we must confront the extreme limitations of human optics when looking into the deep outer void. The apparent brightness of Planet Nine is estimated by astronomers to be incredibly faint, resting at a magnitude that sits far beyond the reach of standard observational equipment. At this extreme level of dimness, The planet is hundreds of thousands of times fainter than the most distant planet we have ever observed directly with ordinary space optics. This lack of visible light is due to the fundamental law of illumination, meaning that sunlight must travel the immense distance out to the planet, lose its strength, reflect off the surface, and then travel that same staggering distance all the way back to Earth. This double dilution of starlight leaves us with a signal so incredibly whispering and fragile that it easily dissolves into the background noise of the night sky. We are looking for a world that exists in a state of nearly perfect optical camouflage, requiring us to develop new ways of collecting and filtering the rare photons that manage to escape its surface. While the planet remains almost completely dark in the visible spectrum of light, it may possess a completely different appearance when viewed through the specialized lens of infrared astronomy. Because Planet 9 is massive, its core should still retain a significant amount of primordial heat left over from its violent formation billions of years ago. This internal warmth, slowly radiating outward through its thick atmospheric layers, would cause the planet to glow softly in the infrared spectrum, even in the freezing cold of the outer solar system. Space telescopes designed to detect infrared signatures have combed through massive amounts of data, seeking this gentle heat signature against the cold backdrop of interstellar space. If we can capture this internal radiation, we will bypass the problem of faded sunlight entirely, turning the planet's own thermal energy into a beacon that reveals its location. It is a captivating thought that a world so profoundly cold on the outside could be guided by a warm heart, shining silently in a spectrum that human eyes cannot naturally perceive. The mathematical behavior of objects moving along highly stretched paths reveals a profound physical concept known to astronomers as aphelion packing, which helps explain why we see these orbits cluster so clearly. According to the fundamental laws of planetary motion, an object traveling on an oval path moves at its absolute fastest when it is closest to the sun, and slows down to a crawl at its farthest point. This simple rule means that these extreme trans-Neptunian objects spend the vast majority of their multi-thousand-year lifetimes lingering at the outermost tip of their journeys, far in the dark. Because they move so slowly in this remote region, they effectively pile up in space, creating a higher density of objects at their farthest points from the sun. Planet 9 exploits this slow lingering, using its massive gravitational influence to organize these distant aphelion points into a tightly gathered group. By focusing our telescopes on the regions where these paths naturally slow down and congregate, we are looking directly at the planetary playground, where the ghost giant exerts its greatest control. The potential discovery of this massive world raises profound philosophical and scientific questions about how we define a true planet within our modern understanding of the cosmos. According to the official criteria established by the international astronomical community, a celestial body must clear its orbital neighborhood of other debris to earn the title of a major planet. Because Planet 9 possesses an immense mass up to 10 times greater than Earth, its gravitational dominance over its vast territory would be absolute, easily fulfilling this scientific requirement. It would completely dwarf all the icy rocks and minor objects scattered throughout the outer Kuiper Belt, acting as the undisputed monarch of the deep solar system. This clear dominance stands in stark contrast to Pluto, which shares its path with millions of other small bodies and was consequently reclassified as a dwarf planet. Finding this hidden giant would not just add another name to our maps, but it would restore a true ninth major member to the Sun's planetary family, validating the classical structure of our solar system. If we were to travel through the darkness and descend into the upper atmosphere of this mysterious world, we would likely find ourselves surrounded by a thick, freezing envelope of elemental gases. Scientists hypothesize that as a mini Neptune, Planet 9 is primarily composed of hydrogen and helium, wrapped around a heavy interior of rock and dense water ice. At these extreme distances from the Sun, the intense cold would cause heavier compounds like methane and ammonia to freeze out completely, drifting down through the atmosphere like a silent, alien snow. This freezing process would leave the upper cloud layers remarkably clear, allowing whatever faint starlight reaches the planet to penetrate deeply into the gas layers before scattering away. The resulting visual effect might be a deeply saturated, dark blue or gray hue, a somber and beautiful color palette suited for a world that rules over the eternal twilight. It is an environment of immense atmospheric pressure and profound stillness, where weather systems move in slow, majestic patterns undisturbed by the warmth of a nearby star. An intriguing consequence of Planet 9's immense gravitational power is the high probability that it is accompanied by its own personal family of icy moons. Throughout the history of our solar system, every giant planet wrapped in gas has managed to capture or form a diverse collection of satellites that orbit around its equator. A world of this size drifting through the crowded outer edges of the Kuiper Belt would act like a massive gravitational magnet, easily snagging passing ice rocks and pulling them into permanent loops. These captured moons would dance in the dark around their giant master, their surfaces coated in ancient frosts that have never been disturbed by intense solar radiation. Some of these satellites might even be large enough to host their own unique geological features, driven by the tidal squeezing forces exerted by the heavy planet's gravity. As we search for the main planet, we must envision a complex, miniature system of worlds moving silently in the deep shadows, a hidden dance within the greater cosmic architecture. To understand why this world remains so hidden from our view, we must also consider the chemical nature of its outer layers and how they interact with incoming light. Astronomers use a concept called albedo to measure how much starlight a celestial body reflects back into space, with lower numbers indicating a darker, more absorbent surface. If Planet Nine's atmosphere or outer crust is rich in complex organic molecules known as tholins, it would possess an incredibly low albedo, absorbing almost all the light that hits it. These tholins, created when ultraviolet radiation slowly bakes simple ices over billions of years, tend to produce a deeply dark, reddish-brown coloration that reflects very little visible light. This dark coating would act as an additional layer of natural stealth, making the planet blend almost perfectly with the black canvas of the interstellar background. The hunt for this giant is therefore complicated not just by the staggering distances involved, but by the very chemistry of the outer solar system, which seems designed to keep this world wrapped in shadow. The survival of Planet Nine in a stable orbit so far from the Sun requires us to explain how it slowed down after being violently ejected from the inner solar system. When the young planet was hurled outward by the immense gravity of giant Jupiter, it would have possessed enough speed to escape the Sun's grip entirely and become a lonely interstellar orphan. However, during that ancient epoch, the solar system was still filled with a thick, fading disk of primordial gas and leftover dust. As the runaway planet plowed through this dense material, the gas exerted a gentle but persistent aerodynamic drag on its motion, gradually sapping its kinetic energy. This cosmic braking mechanism slowed the planet down just enough to prevent its escape, allowing the Sun's weakening gravity to trap it in its current permanent loop. It is a beautiful example of how the chaotic forces of destruction and the gentle forces of resistance worked together to preserve this giant world at the edge of the dark. In the rigorous world of planetary science, researchers must constantly guard against the danger of seeing patterns that are merely illusions created by our own observing habits. Skeptics of the Planet Nine theory often point out the look elsewhere effect, suggesting that we only find aligned orbits because our telescopes are pointed at specific parts of the sky during certain seasons. To address this valid concern, scientists have developed highly sophisticated statistical models to test the true validity of the observed planetary clustering. They simulate thousands of random distributions of outer ice worlds and compare them directly against the real data collected by our best sky surveys. These exhaustive tests consistently demonstrate that the alignment cannot be explained away by observational bias or telescope limitations. The mathematical reality of the clustering survives every attempt to disprove it, reinforcing the quiet certainty that a real physical object is responsible for the order we see. The eventual confirmation of Planet 9 will do far more than simply add a new line to our maps. It will provide an unprecedented window into the dawn of our solar system. Because this world has spent billions of years in the deep freeze of interstellar space, its composition remains largely unchanged since the moment of its birth. Unlike the inner planets, which have been heavily altered by intense solar heat, volcanic activity, and space weathering, this giant acts as a pristine cosmic time capsule. By analyzing its chemical makeup, future scientists will be able to determine the exact ingredients of the original nebula that gave birth to the Sun and all its children. It will allow us to map the distribution of elements in the ancient nursery, answering fundamental questions about how common water and organic materials were during the formation of rocky worlds like Earth. The ghost planet is not just a distant curiosity, but a key to understanding our own deepest history, a silent keeper of the secrets of our creation. When we contemplate the ancient history of our solar system, the mathematical existence of Planet 9 suggests it may have played a critical role during the chaotic epoch known as the planetary migration. Billions of years ago, as the known gas giants shifted their positions and unsettled the surrounding space, a massive storm of icy debris was unleashed across the inner territories. The hidden giant, drifting in its remote domain, would have acted as a distant gravitational buffer during this violent era of cosmic bombardment. Its immense weight allowed it to capture and redirect thousands of these stray planetesimals, either hurling them into the interstellar void or pulling them into the deep reservoir of the outer system. By acting as a silent cosmic shield, this ghost world may have directly influenced the timing and intensity of the impacts that scarred our early moon and brought essential elements to ancient Earth. Understanding this connection allows us to see how a world moving in total isolation could still shape the geological destiny of the inner planets. Consider the fascinating possibility that this hidden giant did not even originate within our own solar nursery, but was instead born around a completely different star. When our sun was young, it resided within a densely packed cluster of sibling stars, where gravitational fields frequently overlapped and brushed against one another in the crowded cosmic cradle. During one of these close stellar flybys, our sun's growing gravitational grip could have intercepted a young planet that had been thrown out by a neighboring star system. This stolen world would have been pulled into a wild, highly tilted path, forever bound to its new stellar master, while retaining the unique chemical fingerprint of its original birthplace. If this captivating hypothesis is eventually proven correct, Planet 9 represents our first reachable alien world, a pristine exoplanet resting quietly at the very edge of our borders. It stands as a beautiful cosmic immigrant, bridging the gap between our local solar family and the wider mysteries of the interstellar wilderness. When we look at the thousands of planetary systems discovered around distant stars across the Milky Way galaxy, we observe a strange discrepancy regarding planetary sizes. The most common types of planets found throughout the universe are those with masses falling squarely between Earth and Neptune, often classified as super-Earths or mini-Neptunes. Yet, when we look at our own familiar planetary lineup, there is a glaring, empty void between our small rocky home and the massive gas giants. Planet 9 perfectly bridges this missing size category, demonstrating that our solar system is actually completely typical within the broader cosmic landscape. Its distant presence fills this evolutionary gap, proving that our home nebula did indeed create this very common galactic child, only to hide it away in the deep freeze of the outer dark. Finding it would reconcile our home system with the rest of the galaxy, showing that we are part of a universal pattern. The mathematical proof for this hidden world relies heavily on a specific orbital property, known to astronomers as the longitude of perihelion. This value describes the exact spatial angle at which a wandering body makes its closest approach to the central sun relative to a fixed point in the cosmos. When researchers mapped this property for the most distant extreme objects, they discovered that these angles were locked within a remarkably narrow, unexpected range. This collective alignment means their paths are not just clustered in space, but their closest points to the sun are all pointing in the exact same direction. Such a strict mathematical restriction requires a continuous, heavy pressure to prevent these angles from naturally twisting apart over millions of years, pointing directly to the stabilizing influence of Planet 9. It is the quiet consensus of these angles that provides the most unyielding evidence for the giant's existence. The search for this elusive giant has recently expanded into a highly innovative arena of astronomy. Utilizing instruments originally designed to study the oldest light in the universe, telescopes tracking the cosmic microwave background, which is the fading thermal echo of the Big Bang, scan the entire sky in millimeter wavelengths with incredible sensitivity. Because Planet 9 radiates its own gentle, internal warmth left over from its creation, it can appear as a tiny, moving point of thermal emission against this cold, ancient radiation backdrop. By reprocessing these massive cosmological datasets, researchers are searching for a faint signature that shifts its position slightly over months of careful observation. This cross-disciplinary effort demonstrates how the tools built to understand the very birth of the cosmos are now helping us decipher the final frontiers of our own planetary neighborhood. It turns the entire sky into a grand mathematical grid where the ghost planet can no longer easily hide. We must address why our historic interstellar explorers, the Voyager and Pioneer spacecraft never detected the gravitational presence of this hidden world during their long journeys into the deep. These legendary probes were launched on highly specific paths designed to maximize encounters with the known gas giants, sending them flying out of the solar system along distinct trajectories. Planet 9 travels along an orbit that is deeply separated from these spacecraft paths, moving through an entirely different quadrant of the vast night sky. Furthermore, even though these probes have traveled for decades, they are still relatively close to the Sun compared to the immense distance where the ghost planet lingers. The silent giant remains far beyond their paths, completely unaffected by our early robotic ambassadors as they drift slowly into the interstellar void. Its isolation protects its secrets from being stumbled upon by accident, requiring a deliberate and targeted effort to uncover. The dynamic relationship between the hidden giant and the inner solar system reveals itself through the slow generation of long-period comets that occasionally grace our night skies. As Planet 9 moves along its highly stretched oval path, its gravity constantly interacts with the inner edges of the distant Oort cloud. This persistent gravitational nudging acts like a slow, celestial valve, occasionally dropping small icy objects out of their stable, remote orbits, and sending them plunging inward toward the Sun. These disrupted travelers transform into brilliant comets, lighting up as they heat up near Earth before returning to the deep dark for thousands of years. Without the quiet work of this massive architect, the supply of these spectacular cosmic visitors would eventually dwindle over geological time. The beautiful comets we observe are often nothing more than pieces of ice shaken loose by the heavy, silent stride of the ghost planet. The modern confirmation of this planetary model requires the use of specialized software known to mathematical physicists as numerical integrators. These highly complex algorithms calculate the gravitational forces between multiple moving objects simultaneously, solving what is known as the n-body problem across vast spans of virtual time. Scientists input the known layout of our solar system, add thousands of synthetic test particles, and let the computer simulations run for billions of years. By watching how these particles respond to different configurations of Planet 9, researchers can slowly eliminate incorrect orbits and refine the true position of the hidden giant. This digital recreation of cosmic history turns pure mathematics into an exploratory laboratory, guiding our physical telescopes toward the most probable hiding places in the night sky. It allows us to explore the dark through the power of computation long before our physical instruments capture the light. Within these complex mathematical simulations, we discover a beautiful concept called secular resonance, which explains the long-term survival of the outer solar system's architecture. This unique resonance occurs when the rate at which an object's orbit twists in space matches up perfectly with the twisting rate of Planet Nine's own massive path. When these frequencies synchronize, they create a stabilized gravitational feedback loop that locks the smaller body into a permanent relationship with the giant. This delicate harmony ensures that even over 5 billion years, the extreme objects are never completely thrown out or destroyed by the giant's presence. It reveals a deeply organized universe where stability is not achieved through rigid stillness, but through a beautifully synchronized rhythm of moving paths. The outer solar system behaves like a massive, slow-motion clock where every gear is bound by the invisible threads of resonance. The ongoing hunt for this hidden world serves as a profound reminder that our mapping of the solar system remains a beautifully unfinished project. For generations, humanity has viewed our stellar neighborhood as a completed puzzle, a static arrangement of planets that we have fully cataloged and understood. Yet, the mathematical reality of Planet Nine shatters this illusion of completeness, showing us that vast, undiscovered territories still exist right on our celestial doorstep. It invites us to maintain a sense of humility and wonder as we look up at the night sky, realizing that the dark spaces between the stars are teeming with hidden structures. The ghost planet continues its slow, silent journey through the deep shadows, waiting patiently for human ingenuity to finally bridge the gap between mathematical certainty and direct visual discovery. When we look at the intricate mechanics of our stellar system, we discover that the true center of mass, known as the barycenter, is not fixed at the exact center of the sun. Instead, the collective weight of all the planets pulls this invisible point slightly outside the physical body of our star, causing the sun to execute a slow, looping dance. The mathematical introduction of Planet Nine shifts this cosmic balancing point even further into the dark, adding a steady, distant weight to the celestial scales. Because this ghost giant resides so far away, its long gravitational arm acts like a heavy counterweight on a massive cosmic lever, subtly altering the geometric center around which everything else revolves. By tracking the precise movements of this invisible barycenter through highly advanced pulsar timing arrays, scientists hope to detect the subtle gravitational signature left by the planet's slow journey. It shows us that even the mightiest star must bow and sway to the collective weight of its distant children. In our current era of exploration, the scientific community is placing its greatest hopes on a monumental new eye opening to the heavens in the high mountains of South America. This revolutionary facility, known as the Vera C. Rubin Observatory, is preparing to conduct an unprecedented 10-year survey of the night sky that will capture the deep universe in motion. Every few nights, its massive digital camera will map the entire visible sky, creating a treasure trove of data that will allow astronomers to detect the faintest moving objects ever recorded. Mathematical models indicate that if Planet 9 lies within the southern sky, this automated survey will almost certainly catch its incredibly dim reflection within its first few years of operation. The sheer volume of information generated by this project will effectively illuminate the dark corners of our neighborhood, leaving no room left for the ghost planet to hide from human curiosity. We stand at the very edge of a technological revolution that will transform our mathematical equations into undeniable visual reality. When we attempt to calculate the physical temperature of this hidden giant, we enter a realm of cold that stretches the boundaries of human imagination. At its immense distance from the central star, the surface of Planet 9 receives almost zero warmth from sunlight, causing its outer layers to hover near a freezing 40 Kelvin above absolute zero. Yet this extreme exterior cold creates a beautiful contrast with the planet's internal reality, where the lingering heat of core compression slowly radiates outward into the void. This delicate thermal profile means that while the planet is completely dead and black to our eyes, it glows like a dim, ghostly ember when viewed through specialized instruments tuned to long infrared wavelengths. By studying the precise balance between this internal heat and the freezing environment of deep space, theoretical physicists can model the exact thickness of its atmospheric blanket. It is a world suspended in a permanent state of cryogenic preservation, frozen on the outside, but keeping a gentle spark of ancient warmth alive in its heart. The elegant mathematical models used to establish the existence of this hidden giant require a very specific balance of mass to explain the survival of the outer ice worlds. If the ghost planet were too small, it would lack the necessary gravitational muscle to organize the chaotic paths of the extreme trans-Neptunian objects over billions of years. Conversely, if its mass exceeded 10 times that of Earth, its heavy gravity would become too destructive, violently scattering the smaller icy bodies and throwing them completely out of the solar system. This narrow window of efficiency tells us that Planet 9 must possess a highly optimized mass, acting as a gentle shepherd rather than a violent cosmic disruptor. The numbers reveal a deep structural harmony, demonstrating that the planet is perfectly sized to maintain the delicate architecture of the outer borders without inducing total chaos. It is this precise calibration of force that allows the system to remain stable across the vast eons of cosmic time. A profound question that often occupies the minds of planetary scientists is how these extreme icy wanderers managed to find themselves in such highly aligned paths in the first place. Computer simulations show that without a massive stabilizing force, the natural gravitational perturbations from the known outer gas giants would completely randomize these orbits, within a few 100 million years. The very fact that we observe these objects tightly clustered together today serves as living proof that an active mechanism is constantly maintaining their order in real time. Planet 9 acts as an eternal cosmic anchor, continuously pulling the straying ice worlds back into their synchronized alignments whenever they begin to drift away. This ongoing preservation means we are not looking at a fleeting remnant of the ancient past, but at a living, dynamic system that is being actively sculpted at this very moment. The survival of these lonely travelers is a silent testament to the constant, watchful presence of the hidden giant. The mathematical blueprint of this hidden world does not just describe its mass and distance, but also specifies the unique tilt of its own path through the cosmos. The equations suggest that Planet 9 does not orbit within the flat, orderly plane shared by Earth and the other familiar planets, but is instead tilted at a steep angle of roughly 30 degrees. This significant inclination means that the ghost giant spends most of its multi-thousand-year journey traveling high above or deep below the main disk of our solar system. This vertical separation explains why early sky surveys, which focused primarily on the flat planetary plane, completely missed the faint signature of this massive world. By lifting itself out of the crowded stellar highway, the planet has maintained its deep secrecy, charting a lonely path through the empty northern and southern skies. To find it, we must expand our horizons and look far beyond the traditional boundaries of our planetary floor. Long before our newest observatories began scanning the heavens, early clues about this hidden giant may have already been captured and stored within our vast digital archives. Teams of dedicated astronomers are currently using powerful machine learning algorithms to comb through decades of historical data collected by older space surveys, such as the Wide Field Infrared Survey Explorer. These advanced digital systems filter through billions of stationary stars and distant galaxies, searching for a single microscopic dot that shifts its position over years of observation. It is entirely possible that the ghost planet has already been photographed by human instruments, its faint light resting silently on a server disk, waiting for someone to connect the mathematical dots. This archival hunt turns modern astronomy into a form of cosmic archaeology, where the great discoveries of tomorrow are unearthed from the digital records of yesterday. It reminds us that sometimes the greatest secrets of the universe are already in our possession, waiting only for the right question to unlock them. As we map the immense orbit of this hidden world, we realize that its journey carries it to the very edge of the sun's magnetic domain. The heliosphere, which is the vast protective bubble carved out by the solar wind against the interstellar medium, ends at a boundary known as the heliopause. At the farthest point of its highly stretched path, Planet 9 may actually cross this invisible frontier, stepping out of the sun's immediate protective embrace and entering the raw wilderness of interstellar space. This means the planet spends a significant portion of its life directly exposed to the high-energy cosmic rays and interstellar winds that flow between the stars. It acts as a lonely scout, crossing the boundary line between our domestic stellar home and the grander galaxy before diving back toward the warmth of the inner system. Studying how a massive world interacts with this boundary zone could provide invaluable insights into the true nature of the space that shields our solar system from the wider universe. In the rigorous pursuit of scientific truth, researchers must always test alternative explanations before accepting the existence of a completely new planet hidden in the dark. Physicists explored whether the strange alignment of the outer ice worlds could be explained by modifying our understanding of gravity itself. Using theories like modified Newtonian dynamics, they calculated whether subtle adjustments to the laws of physics at extreme distances could replicate the observed clustering without needing a physical object. However, when these alternative mathematical models were put to the test, they failed to reproduce the precise three-dimensional tilts and perpendicular paths discovered in the outer system. The unyielding laws of standard general relativity remained the only framework that perfectly matched the data, provided a massive planet was present in the dark. This thorough elimination of alternative physics solidifies the reality of Planet 9, proving that our equations do not need to be rewritten, but rather followed to their logical conclusion. There is a profound psychological shift that occurs within the human consciousness when we realize that our celestial home is far larger and more mysterious than we ever imagined. For generations, we have comforted ourselves with the idea of a fully mapped and predictable solar system, a tidy neighborhood where every major resident has been named and categorized. The mathematical ghost of Planet 9 shatters this complacency, reminding us that we are still primitive explorers standing on the shores of a vast, uncharted ocean. It is an inspiring thought that a massive world has been drifting silently in our night sky throughout the entire rise and fall of human civilization, completely oblivious to our history. Its eventual discovery will serve as a beautiful monument to human curiosity, proving that the mind can pierce the deepest shadows of space using nothing more than the elegant language of mathematics. It invites us to look up at the dark spaces between the stars not with fear, but with the quiet anticipation of an untold story waiting to be read. When we evaluate the long-term journey of this hidden world, we must marvel at the extraordinary stability of its orbit across billions of years of cosmic history. Even though it travels through the most remote and fragile borders of the sun's influence, it manages to resist the destabilizing pulls of passing stars in our galactic neighborhood. Mathematicians calculate this longevity by measuring the gravitational boundaries of our solar system, ensuring that the planet remains firmly caught within the sun's deep well. This enduring orbit means the ghost giant has completed thousands of slow loops since the dawn of our world, never straying far enough to escape into the open galaxy. It exists in a delicate celestial equilibrium, a permanent resident of the outer dark, whose path is carved deeply into the long-term structure of space. The mathematical equations guarantee that this distant guardian is not a passing traveler, but a foundational pillar of our planetary architecture. The evidence for this hidden giant becomes even more compelling when astronomers examine a specific structural feature, known as the alignment of ascending nodes. This technical concept describes the exact points where the paths of distant ice worlds cut upward through the main flat plane of our solar system. Instead of crossing this cosmic floor at random locations, these distant wanderers choose to pass through it within a tightly defined and clustered region of space. This second layer of geometric alignment adds a powerful dimension to our mathematical proofs, showing that the order we see is truly three-dimensional. A massive object must be sitting at a precise orientation in the dark, acting as a gravitational guide that forces these crossing points to gather together. It is the silent coordination of these nodal intersections that leaves an undeniable signature, proving that an organized force is actively shaping the geometry of the deep outer dark. To understand the true layout of this remote territory, we must observe how the solar system is divided into distinct planetary empires based on gravitational control. In the regions closer to us, giant Neptune holds absolute dominion over a chaotic family of icy rocks known as the scattered disk, constantly altering their paths with its heavy pull. However, as we move further out into the deep shadows, Neptune's gravitational grip fades into nothingness, leaving a vast and quiet void. It is precisely in this remote zone that the influence of Planet 9 begins, taking over the governance of the detached objects that Neptune can no longer reach. This clear boundary between the two planetary empires reveals a beautiful transition of power, where one giant yields to another across the silent expanse. The existence of these detached worlds proves that the outer solar system is not an empty wasteland, but a highly structured realm ruled by an unseen monarch. As the search for this elusive giant continues, astronomers are exploring a highly creative method of detection known as occultation astronomy, which relies on the movement of distant stars. Because Planet 9 is too dark to reflect significant sunlight, scientists hope to catch its silhouette as it slowly drifts in front of the brilliant stars that populate the background galaxy. When the planet passes directly between Earth and a distant star, it will briefly block the starlight, causing the star to mysteriously blink out of existence for a few fleeting moments. by coordinating vast networks of ground telescopes to constantly monitor thousands of stars simultaneously. Researchers hope to record one of these rare cosmic eclipses. This method turns the entire background of our galaxy into a giant light board, where the passage of the ghost planet is revealed by the temporary shadows it casts. It is a testament to human ingenuity that we can find a completely dark world by watching the light of stars that reside trillions of miles away. While our deepest telescopes scan the outer horizons, highly sensitive measurements of the inner rocky planets are providing silent constraints on where this hidden giant can reside. Scientists utilize highly advanced planetary ephemerides, which are incredibly precise mathematical tables that track the exact positions of Earth, Mars, and the Moon over decades of observation. Because gravity is a universal thread that connects all matter, the immense mass of Planet 9 should cause a microscopic, nearly imperceptible tug on these inner worlds. By comparing our real-world tracking data against these perfect mathematical models, researchers can look for tiny variations that might indicate an outside pull. The fact that our inner planets move with absolute precision tells us that the hidden giant must be located within a specific distant arc of its orbit. This cosmic tracking system allows us to use our own home planet as a delicate instrument, narrowing down the hiding places of the ghost world through the silent perfection of its motion. A fascinating consequence of Planet 9's extreme distance from the Sun is the monumental size of its personal zone of gravitational dominance, known to physicists as its Hill sphere. Near the Sun, a planet's Hill sphere is relatively small because the star's immense gravity easily overpowers and reclaims any nearby objects. In the deep dark where the hidden giant dwells, the Sun's grip is incredibly weak, allowing Planet 9 to extend its gravitational hands across a massive expanse of empty space. This giant pocket of dominance means that the planet could easily hold onto a vast network of moons and icy debris across distances of millions of miles. Any small object entering this massive sphere would be instantly captured, pulled into a slow and permanent dance around the freezing gas giant. The ghost world rules over a colossal territory, a miniature solar system existing silently within the grander framework of our stellar home. The validity of this mathematical model was recently reinforced by the discovery of a highly unusual extreme object known to science as 2015 BP 519. This distant icy traveler baffled astronomers because its path is tilted at an astonishing angle of 54 degrees relative to the flat plane where Earth resides. Such an extreme tilt is completely inexplicable using standard solar system models, as no known planet possesses the power to lift an object so high into the northern sky. However, when researchers introduced Planet 9 into their computer simulations, They found that the giant's gravity naturally pushes small objects into these exact vertical paths over long periods. The discovery of this bizarre world served as a stunning vindication of the theory, proving that the mathematical equations could explain the most radical anomalies in our system. It demonstrated that what appeared to be a wild cosmic misfit was actually moving in perfect accordance with the hidden planet's grand design. To understand how this hidden world came to be, scientists are using its estimated mass to calculate the total amount of material that must have existed in the early protoplanetary disk. The creation of an object 5 to 10 times more massive than Earth requires a massive reservoir of gas and dust to be present during the first few million years of our sun's life. By analyzing the mathematical requirements for building Planet 9, researchers can determine the true density and scale of the ancient nebula that gave birth to our planetary family. This data shows that our early solar system was likely far richer and more expansive than previously believed, possessing enough raw material to build giants far beyond the current orbit of Neptune. The ghost planet acts as a living monument to this ancient abundance, a remnant of a time when the space around our young star was a dense, swirling ocean of creative potential. It allows us to rebuild the ancient nursery in our minds, guided by the physical weight of this distant survivor. The chemical nature of this hidden giant is deeply tied to the specific timing of its core formation during the chaotic infancy of our stellar neighborhood. If the planet's rocky core grew rapidly within the inner solar system, it would have possessed enough gravitational strength to pull in a thick blanket of hydrogen and helium gas before the solar wind swept those elements away. This rapid growth would make Planet 9 a true sibling to Jupiter and Saturn, sharing the exact same primordial ingredients that built the great gas giants of our system. If it had formed slower or further out, it would be a bare world of rock and ice, lacking the majestic atmospheric envelope that defines the mini Neptunes of the galaxy. The mathematical simulations of its ejection suggest that a gaseous nature is far more likely, pointing to a world of deep atmospheric currents and eternal storms. It represents a forgotten chapter of our solar system's birth, a world that shared our origins but was denied a place in the light. As we contemplate the vast amount of evidence supporting this hidden world, we must appreciate the beautiful concept of a mathematical shadow that guides modern scientific discovery. We live in an era where our understanding of reality has expanded far beyond what our physical eyes can directly see or touch. Just as we detect distant black holes by the light they warp, or ancient subatomic particles by the tracks they leave behind, we map Planet 9 through the order it imposes on the outer dark. The ghost planet exists as a perfect mathematical shadow cast across the orbits of the furthest ice worlds, its form clearly outlined by the laws of physics. This indirect knowledge carries a profound philosophical weight, reminding us that truth is often found not in the bright glare of direct observation, but in the quiet, consistent patterns left in the darkness. We continue our journey through this mathematical landscape, confident that the shadow will eventually lead us to the physical world, waiting silently at the end of the dark. Let us consider an extraordinary and radical alternative theory that has captured the imagination of theoretical physicists searching for this hidden mass. Some scientists suggest that the gravitational anomaly we attribute to a large gas planet could actually be caused by a primordial black hole, an ancient entity formed during the very first moments of the Big Bang. This hypothetical object would possess the exact same mass as Planet 9, ranging from 5 to 10 times the weight of our Earth. Yet it would be packed into a space no larger than a bowling ball or a grapefruit. Because it would produce no light and reflect absolutely no sunshine, it would remain completely invisible to every traditional optical telescope on Earth or in space. To verify this exotic possibility, researchers are looking for flashes of light caused by tiny interstellar comets crashing into its event horizon, releasing a sudden burst of energy in the dark. While a planetary nature remains far more likely, this mind-bending hypothesis reminds us that the outer dark could hold physics far more mysterious than we ever dared to dream. The mathematical influence of this hidden giant reveals itself not just in the paths of individual ice worlds, but in a subtle, large-scale bending of the entire outer Kuiper Belt. When astronomers plot the three-dimensional coordinates of thousands of icy rocks drifting past Neptune, they notice that the outer edges of this debris disk are not completely flat. Instead, the distant disk appears warped and twisted, curving away from the main planetary plane in a gentle, elegant wave that mirrors the predicted path of Planet 9. This collective deformation is exactly what we would expect from a heavy companion planet moving on a tilted orbit, pulling the surrounding material toward its own unique plane over billions of years. It is as if the ghost giant has left its massive footprint pressed deeply into the fabric of the outer solar system, reshaping the layout of the debris. By mapping the precise curves of this cosmic warp, mathematicians can calculate the gravitational pressure needed to bend such a vast field of rocks, narrowing down the mass of the unseen architect. Our search for this elusive world has benefited immensely from advanced sky mapping projects that were originally designed to solve the deepest mysteries of the grander universe. The Dark Energy Survey, utilizing an exceptionally powerful camera in the high deserts of Chile, spent years scanning vast patches of the southern sky to study the acceleration of distant galaxies. While looking out into the deep cosmos, this sensitive instrument simultaneously captured thousands of icy points of light, moving quietly within our own solar system's backyard. Astronomers reprocessed this massive treasure trove of data, discovering several new extreme trans-Neptunian objects that fit perfectly into the aligned pattern established by the Planet 9 model. This unexpected bonus demonstrated how a project built to explore the edges of the universe could provide vital clues about our own immediate neighborhood. Each new ice world found in these deep fields adds another firm point to our mathematical map, bringing us closer to the final hiding place of the ghost planet. To appreciate the ancient relationship between the hidden giant and its small icy companions, we must understand the immense timescales required for gravity to organize these orbits. Mathematical models reveal that it takes hundreds of millions of years for Planet 9 to gently nudge a normal Kuiper Belt object out of its original path and turn it into a detached world. This slow, patient process means that the alignment we observe today is the result of a continuous gravitational conversation that has been unfolding since the solar system was young. The current layout of these extreme objects acts as a living record of cosmic stability, proving that the giant has been maintaining this order across billions of eons. If the hidden planet were a recent addition to our solar system, it would not have had enough time to sculpt these distant paths into such a harmonious and tightly clustered pattern. The very existence of this beautiful alignment is a testament to the eternal and unchanging presence of the unseen guardian in the outer dark. When theoretical astronomers attempt to simulate the exact reflective properties of Planet 9, they must account for the extreme behavior of chemical compounds at near absolute zero temperatures. If this world is a mini Neptune wrapped in gas, its upper atmosphere would likely contain significant amounts of methane gas, similar to the blue worlds we know. However, at the mind-chilling distance where the ghost planet resides, this methane gas would undergo a dramatic physical transformation, completely freezing out into a brilliant, crystalline frost. This solid ice would coat the upper cloud layers, changing the way the planet reflects the incredibly faint starlight that reaches its remote domain. Instead of appearing as a soft, absorbing gas ball, the planet might possess a highly reflective, shiny surface that acts like a cracked cosmic mirror in the dark. Understanding this unique chemical freeze-out allows scientists to adjust their telescope filters, looking for a specific icy glint that distinguishes the planet from common background stars. The heavy gravitational pull of Planet 9 reaches far beyond its immediate neighborhood, subtly affecting a transient population of icy bodies known to science as centaurs. These unstable objects constantly cross the paths of the giant planets, transitioning from the cold outer reservoirs into the warmer regions of the inner solar system. Computer simulations show that the ghost planet acts as a distant celestial gatekeeper, organizing the initial trajectories of these objects long before they ever get close to Neptune or Uranus. By analyzing the unique entry angles of these incoming centaurs, astronomers can trace their past journeys back into the deep shadows where the hidden giant rules. This backward mathematical tracing reveals that a significant fraction of these icy wanderers were directed inward by the specific gravitational torque of Planet 9. It shows that the ghost planet is actively feeding new material into the inner solar system, influencing the cosmic traffic that moves through our own planetary neighborhood. To solve the mystery of how Planet 9 arrived in its highly stretched orbit, we must examine the role of the dense gas that filled our sun's native stellar cluster. When our star was born alongside hundreds of siblings, the entire region was awash in a thick, swirling fog of molecular hydrogen that exerted a steady resistance on moving bodies. If the young planet was violently hurled outward by the inner gas giants, this primordial gas would have acted as a dense cushion, slowing its runaway speed before it could escape into the open galaxy. The mathematical equations of fluid dynamics allow scientists to calculate exactly how much gas drag was necessary to capture the planet and settle it into its current permanent loop. This calculation provides an invaluable window into the density and lifespan of our sun's original nursery, linking the planet's orbit to the very environment that created our solar system. The ghost planet remains a beautifully preserved relic of that ancient gas ocean, its current path shaped by the long-vanished winds of our stellar birth. A fascinating and counterintuitive result of the mathematical models is that the presence of Planet 9 actually enhances the long-term dynamic stability of our entire solar system. One might assume that adding a massive, highly tilted planet to the outer edge would introduce dangerous chaos that could eventually disrupt the interplanetary family. However, supercomputer simulations running for billions of virtual years show that the unique anti-lined orbit of the giant acts as a stabilizing anchor for the inner worlds. Its steady, distant pull helps neutralize the subtle chaotic resonances that naturally build up between giant Jupiter and the other gas planets over eons of time. It behaves like a heavy balancing weight on a spinning wheel, smoothing out the vibrations and ensuring that the entire system moves with predictable, clockwork precision. Finding this hidden world would reveal that our planetary home is not a fragile arrangement prone to sudden collapse, but a beautifully engineered masterpiece of gravitational balance. Because Planet 9 spends its long life at the ultimate frontier of the sun's influence, its surface and atmosphere are subjected to a unique environmental baking process. Far beyond the protective magnetic shield of the inner heliosphere, the planet is completely exposed to the full, unshielded force of galactic cosmic rays and high-energy interstellar radiation. Over billions of eons, this continuous subatomic bombardment breaks down simple molecules in its upper layers, forging complex organic polymers that coat the planet in a dark, radiation-hardened crust. This ancient chemical seasoning alters the expected signature of the world, making its exterior remarkably resilient to change, while locking away the pristine ingredients of its birth beneath a dark shroud. By studying how interstellar radiation interacts with a mini Neptune atmosphere, theoretical astrobiologists can predict the unique chemical pathways that unfold in the deep cold. It transforms the ghost planet into a grand natural laboratory, testing the limits of chemistry in the most extreme environment of our stellar system. The eventual visual discovery of this massive companion will fundamentally redefine our understanding of where our true celestial home ends and the open galaxy begins. For decades, humanity viewed the edge of the solar system as a sharp, sudden drop-off marked by the icy domain of Pluto and the inner Kuiper Belt. Planet 9 completely shatters this narrow view, proving that the Sun's planetary empire extends hundreds of times further into the dark wilderness than we ever believed possible. It expands the physical boundaries of our neighborhood, filling the vast, silent void between the known planets and the incredibly distant outer Oort cloud, with a structured, heavy presence. This realization changes our psychological relationship with the cosmos, transforming the empty dark into a familiar territory, ruled by the same elegant laws that govern Earth. We are learning to see our solar system not as a small, isolated island, but as an expansive, beautifully connected realm that reaches out to embrace the infinite silence of interstellar space. As we deepen our mathematical understanding of this hidden empire, we observe that the ghost planet acts as a sophisticated dynamical filter for the entire outer solar system. Over the course of thousands of centuries, its massive presence systematically cleanses its vast orbital territory, destabilizing any small ice worlds that drift into unharmonious paths. This relentless gravitational filtering ensures that only the most resilient and perfectly synchronized objects can survive on their elongated paths without being cast out into the interstellar void. The extreme objects we see today are the proud survivors of this ancient process of natural selection, their very existence proving they have found a safe refuge within the giant's complex gravitational web. It reveals a highly selective architecture where chaos is quietly pruned away, leaving behind a beautifully organized community of synchronized worlds. This elegant filtering mechanism demonstrates that the outer system is not a random collection of debris, but a carefully curated family of objects moving under a singular rule. The immense scale of this celestial hunt has inspired an extraordinary collaboration that unites advanced astrophysics with the collective power of human curiosity across our entire globe. through specialized citizen science projects. Hundreds of thousands of ordinary volunteers are currently combing through massive public catalogs of infrared sky images captured by our best space telescopes. These dedicated individuals use their own eyes and minds to detect the subtle, microscopic shifts of dim points of light that automated computer algorithms might easily overlook against the crowded background of distant stars. This global effort turns the search for Planet 9 into a shared human adventure, breaking down the traditional boundaries between professional researchers and passionate stargazers. It is a beautiful realization that the definitive clue revealing our solar system's hidden giant might eventually be discovered by a volunteer sitting quietly at home, looking deeply into the dark fields of digital space. This democratic pursuit of knowledge reminds us that the mapping of the universe is a collective responsibility, driven by an innate human desire to understand the unknown. When mathematicians calculate the most likely current position of Planet 9 along its multi-thousand-year path, they find that it is likely lingering near its farthest point from the Sun, situated against an incredibly crowded celestial backdrop. This specific region of the night sky happens to overlap with the brilliant, star-dense plane of our own Milky Way galaxy, near the familiar constellations of Taurus and Orion. This unfortunate cosmic positioning complicates our search immensely, as the faint, frozen reflection of the ghost planet is easily lost among millions of bright, glittering background stars and glowing nebulae. It is as if the universe has chosen the most cluttered closet in our solar system to hide its most profound planetary secret, forcing astronomers to develop incredibly precise filtering methods to separate the local wanderer from distant stellar giants. Despite these severe visual challenges, observers remain patient, systematically mapping this complex tapestry of light with the quiet confidence that the planet's slow, distinctive motion will eventually betray its hiding place. The search through this brilliant stellar forest requires a delicate balance of technological precision and enduring dedication to refine our understanding of how the hidden giant shapes its environment. Modern astrophysicists construct massive synthetic solar systems containing millions of virtual test objects. They subject these digital universes to different variations of Planet 9's mass, distance, and orbital tilt, watching how the simulated ice worlds evolve over billions of virtual years. By analyzing the survival rates and final configurations of these synthetic bodies, researchers can compare them directly with the real extreme trans-Neptunian objects observed by our physical telescopes. If a specific digital model fails to reproduce the exact clustering and tilts we see in the real universe, that particular configuration is permanently eliminated from our calculations. This continuous process of mathematical elimination allows scientists to narrow down the true physical properties of the ghost planet with remarkable accuracy, turning pure computation into a sharp exploratory tool. The numbers flowing through these digital laboratories provide a highly reliable blueprint of a world we have not yet touched with light. The far-reaching arm of Planet Nine's gravity leaves a subtle but distinct signature on the structure of the classical Kuiper Belt, located much closer to the known planets. Within this ring of ancient icy debris, astronomers have discovered a strange, highly concentrated population of objects known to science as the kernel. While standard planetary models struggle to explain why so many icy rocks would gather so tightly within this specific narrow band of space, the mathematical introduction of the ghost planet solves the mystery elegantly. The distant giant's slow orbital movement generates a gentle, sweeping gravitational resonance that acts like a cosmic rake, slowly gathering these classical objects into a dense, synchronized group over long eons of time. The presence of the kernel serves as a beautiful local echo of the giant's distant power, a physical feature in our immediate cosmic backyard that is directly sculpted by an object lurking billions of miles away. It shows us that the architecture of the solar system is deeply interconnected, where the smallest structures feel the steady pulse of the largest hidden masters. The specific pattern of alignments we observe among the furthest ice worlds provides vital clues about the exact timing of Planet Nine's ancient journey into the outer dark. If the young planet had been violently thrown outward during the very first few million years of the solar system's birth, it would have left a completely different gravitational footprint than if its migration occurred much later. Mathematicians test these different historical scenarios by calculating the orbital relaxation times required for the extreme trans-Neptunian objects to settle into their current synchronized paths. These calculations reveal that the beautiful clustering we see today requires a slow, steady cultivation that must have unfolded over a vast span of billions of years. This long timeline suggests that the ghost planet has been quietly ruling its remote empire since the very dawn of our world, acting as a permanent and stable fixture throughout the entire evolution of our planetary family. It transforms the planet from a temporary cosmic anomaly into an ancient founding member of the Sun's household. As ground-based telescopes push the absolute limits of what is possible through Earth's atmosphere, scientists are designing revolutionary space-based concepts to illuminate the deep outer system. Future missions envision vast constellations of miniature space telescopes placed in strategic orbits far beyond the disruptive glare of our home planet. These synchronized robotic eyes would not look for the faint, reflected sunlight of Planet Nine directly, but would instead monitor millions of background stars simultaneously with extreme temporal precision. By tracking the microscopic variations in starlight caused by the passage of distant objects, this orbital network could map the entire outer Kuiper Belt in 3 dimensions through the power of stellar occultations. Such an advanced technological shield would easily catch the silhouette of the ghost giant as it slowly cuts across the stellar background, revealing its exact size and path without needing a single photon of direct solar reflection. It represents the ultimate evolution of our observational capabilities, turning the empty void into a highly responsive web of light. While the heavy presence of Planet 9 actively shapes the wild paths of the outermost ice worlds, it leaves the inner sanctuaries of our solar system completely undisturbed on human timescales. The delicate orbits of Earth, Mars, and our Moon remain perfectly stable, insulated from the distant giant's pull by the immense distances and the protective gravitational fields of giant Jupiter and Saturn. Yet, when mathematicians extend their equations across hundreds of millions of years, they discover that this hidden world acts as a subtle regulator for the entire solar system's long-term clock. Its slow, majestic looping generates a gentle, macro-scale oscillation that helps prevent the inner planetary paths from ever locking into dangerous, destabilizing rhythms. This grand cosmic harmony ensures that our home planet remains within its safe, life-supporting zone for billions of eons, protected by the very architecture that includes this distant ghost. It is a profound realization that the stability of our own quiet nights on Earth is intimately connected to the heavy, silent stride of a giant world moving through the outer darkness. If we were to stand on the frozen upper cloud layers of Planet 9 and look back toward the warm heart of our solar system, our understanding of cosmic perspective would be fundamentally transformed. From that immense distance, the mighty sun would appear as nothing more than an exceptionally bright, piercing needlepoint of starlight, entirely incapable of casting a noticeable shadow or providing felt warmth. The giant planets we know so well, like Jupiter, Saturn, and Neptune, would be completely invisible to the naked eye, huddled so tightly against the brilliant glare of the central star that they would blend into a single point of light. Our home Earth would be a microscopic, unreachable speck lost entirely in the solar glare, a forgotten dust mote in a vast ocean of absolute shadow and silence. This remote vantage point forces us to realize how small and fragile our local empire truly is within the grand context of the wider universe. It invites us to view our existence with a sense of deep humility, recognizing that the boundaries of our home are far vaster than the tiny circle we inhabit. The ongoing scientific journey to uncover Planet 9 represents one of the greatest triumphs of predictive mathematics in human history, echoing the classical discoveries of the past. Just as the existence of Neptune was famously calculated using pen and paper before a telescope was ever pointed toward its blue clouds, this hidden giant is being systematically brought to light through the pure power of logic and gravitational physics. The unified mathematical theory connects 5 entirely independent cosmic clues: the clustering of paths, the shared orbital tilts, the existence of detached worlds, the vertical loops of perpendicular travelers, and the warping of the outer disk, into a single, elegant solution. It is mathematically impossible for a single false concept to accidentally explain so many distinct and complex anomalies simultaneously across such a vast expanse of space. This perfect alignment of theory and observation fills researchers with a quiet, unyielding certainty that the ghost planet is real, waiting silently at the coordinates carved out by our equations. The math has already crossed the dark void, leaving human eyes to simply follow the path that numbers have so clearly drawn. As we reach the final summit of our mathematical exploration, we must look at how the presence of this hidden giant resolves the overall structural orientation of our entire planetary plane. For decades, astronomers accepted the flat disk of our solar system as an unchanging foundation. Yet the steady pull of Planet 9 introduces a slow, magnificent warp that operates over spans of hundreds of millions of years. This distant weight exerts a continuous gravitational torque on the inner planets, causing their collective orbital floor to slowly drift and wobble against the backdrop of the deep stars. By measuring this macro-scale warping effect, celestial mechanics can trace the long-term history of our cosmic neighborhood, revealing that our planetary home is not rigidly fixed in place. The ghost planet acts as a grand balancing scale, its massive orbital tilt slowly pulling the inner world system out of its original alignment and carving a new path through space. This realization unifies the movements of the closest planets with the mysteries of the furthest dark, showing that every world is bound to the same grand design. The true longevity of this unique cosmic arrangement is validated by the mathematical laws of survival across the immense age of our solar system, which has persisted for more than 4.5 billion years. If the path of Planet 9 were unstable, the chaotic interactions with the inner gas giants would have either thrown it into the interstellar wilderness or pulled it into a destructive collision long ago. Instead, highly advanced computer models demonstrate that the planet occupies a rare, highly optimized pocket of stability that allows it to survive indefinitely without ever disrupting its neighbors. This perfect long-term preservation proves that the hidden world is a permanent anchor of our stellar family. Its slow loop through the dark, perfectly calibrated to match the natural rhythms of the sun. it exists in a state of permanent grace, a silent survivor of the violent ancient epic that reshaped the early cosmos. By analyzing the boundaries of this stable zone, scientists can place incredibly strict limits on the planet's trajectory, knowing that its path must conform to the strict requirements of deep time. The translation of these complex gravitational patterns into a precise map of the night sky relies heavily on the immense processing power of our most advanced modern supercomputer clusters. Researchers utilize vast networks of graphic processing units to simulate billions of virtual particles, tracking their movements across simulated eons in a matter of hours. These digital universes allow astronomers to observe how the subtle gravity of Planet 9 interacts with the distant Kuiper Belt, creating visual models that can be directly compared with our real telescopes. When the digital simulations perfectly recreate the exact clustering and orbital tilts we observe in nature, scientists know they are closing in on the true layout of the cosmos. This continuous feedback loop between pure computation and physical observation turns the hunt for the ghost planet into a masterpiece of modern predictive science. The numbers flowing through these glowing machines are slowly peeling back the shroud of darkness, transforming a mathematical ghost into a tangible destination. A beautiful principle of modern scientific thought is the requirement of parsimony, which dictates that the most elegant explanation requiring the fewest assumptions is almost always the correct one. Before the mathematical model of Planet 9 was introduced, astronomers were forced to create separate, disjointed theories to explain each individual anomaly discovered in the outer solar system. They needed one theory for the unique path of Sedna, another for the highly tilted vertical travelers, and yet another for the sudden drop-off at the edge of the classical debris disk. The ghost planet model sweeps away this cluttered confusion, offering a single, unified explanation that gracefully accounts for all 5 major anomalies simultaneously through the simple laws of standard gravity. This incredible explanatory power is the ultimate hallmark of a true scientific breakthrough, demonstrating that what appeared to be separate mysteries are actually different reflections of a single massive presence. The math brings absolute clarity to the outer dark, organizing a chaotic wilderness into a harmonious and comprehensible family of worlds. The physical boundaries of our searching telescopes have been heavily refined by the exhaustive data collected during previous sweeping surveys of the northern and southern hemispheres. Advanced mapping projects, such as the Pan-SDARRS telescope array, have carefully cataloged billions of dim stars and moving objects, systematically eliminating vast swathes of the sky where the giant planet could easily have been spotted. This thorough process of elimination has narrowed the remaining search grid down to a highly specific, narrow corridor located near the farthest point of the planet's elongated journey. Because the planet moves at its absolute slowest speed in this remote region, it remains lingering within this specific field of stars for centuries, waiting for human ingenuity to isolate its faint glow. This concentration of effort allows astronomers to focus their most powerful instruments on a well-defined planetary playground, maximizing the chances of direct visual confirmation. The grid is shrinking every year, pushing the ghost world out of its hiding places and closer to the light of human understanding. Theoretical calculations regarding the physical dimensions of Planet 9 suggest that it possesses a compact yet substantial scale, fitting perfectly into the mass density profile of a mini Neptune. With a mass roughly 5 to 10 times greater than Earth, its internal gravitational pressure would pull its gaseous envelope into a sphere with a radius 2 to 4 times larger than our home world. This specific size makes it significantly smaller than giant Neptune or Uranus. Yet it remains completely dominant over any rocky planet within our solar system's lineage. The planet's dense interior core, composed of heavy iron and silicate rock, would be wrapped in a thick, highly compressed layer of water ice and exotic fluid mantles under immense atmospheric pressure. This compact composition ensures that while the planet carries an immense gravitational signature, its physical silhouette remains relatively small against the vast expanse of the outer void. It represents a unique class of planetary architecture, a heavy and highly concentrated world drifting quietly in the deep freeze of space. The eventual confirmation of Planet 9 will easily satisfy the official scientific criteria established to define a major planet, reinforcing its position as a true monarch of the outer darkness. According to these rigorous cosmic rules, a celestial body must possess enough mass to clear its entire orbital pathway of any competing debris or smaller wandering rocks. Because the ghost giant carries a mass that completely dwarfs the collective weight of the entire Kuiper Belt, its gravitational dominance over its colossal territory is absolute and unquestioned. It does not share its path with a cloud of scattered debris like dwarf Pluto, but rather acts as the supreme architect that actively shapes and organizes the journeys of everything around it. This undeniable clearing power elevates the hidden world far above the ranks of minor ice rocks, ensuring its rightful place as the 9th major member of the Sun's planetary household. Finding it will restore a beautiful balance to our maps, confirming that a true planetary empire extends out into the deepest shadows of the solar domain. The discovery of this remote giant will instantly ignite the imagination of the global scientific community, inspiring the creation of the most ambitious robotic exploration missions ever conceived by humanity. Theoretical engineers are already drafting preliminary concepts for ultra-rapid transit probes powered by advanced nuclear thermal propulsion or massive interstellar solar sails driven by powerful ground-based lasers. These highly advanced spacecraft would be capable of traveling across the vast void at unprecedented speeds, bridging the immense distance to Planet 9 within a single human lifetime. As these robotic ambassadors approach the hidden world, they will send back the very first close-up images of its dark blue cloud decks, its captured families of frozen moons, and the pristine environment of its ancient atmosphere. Such a mission would represent the ultimate frontier of human spaceflight, stretching our technological capabilities to the absolute limit as we reach out to touch a world born in the deep dark. It transforms the planet from a distant mathematical abstraction into a real, physical destination waiting to be explored by our mechanical children. When we synthesize all the mathematical proofs collected across the last decade of intensive research, the statistical certainty supporting the existence of Planet 9 becomes truly unyielding. The probability of the aligned orbital ovals, the shared three-dimensional tilts, the existence of detached worlds, and the creation of perpendicular tracks occurring by pure coincidence drops to a tiny fraction of a single percent. In the rigorous language of probability, it is statistically nearly impossible for the universe to display such a highly organized, complex pattern without a physical object actively generating the order. This overwhelming convergence of data leaves Planet 9 as the most conservative, logical, and scientifically sound explanation available to modern astrophysics. The theory does not rely on speculation or hope, but on the unyielding physics of celestial mechanics and the quiet certainty of geometric alignments. The mathematical case is closed, leaving our physical instruments to simply complete the final task of capturing the rare photons that escape its frozen surface. We stand now at the absolute precipice of a monumental historical moment, where the boundary between mathematical prediction and direct visual discovery is about to dissolve forever. Throughout the long history of human civilization, our understanding of our stellar home has expanded in sudden, beautiful leaps. Whenever our eyes have caught the light of a previously hidden world, the silent hunt for Planet 9 is approaching its natural conclusion, driven forward by the imminent activation of the most powerful sky surveys ever constructed by human hands. Somewhere out in the deep northern or southern sky, resting quietly against a crowded backdrop of a million distant stars, a single microscopic dot of light is moving with a slow, distinctive rhythm that obeys our equations. The transition from a mathematical shadow into a verified pixel of light on an astronomer's computer screen will rewrite our textbooks and redefine our place in the cosmos forever. The ghost planet continues its eternal, majestic loop through the deep shadows, waiting patiently for the moment when human curiosity finally pierces the darkness to welcome the final child of the sun into the light. Our long, drifting journey through the mathematical architecture of the outer solar system now draws to its natural, quiet close. We have traveled far beyond the familiar blue horizons of Earth, past the massive gas giants, and into the silent territory where Pluto and the extreme ice worlds trace their lonely paths. Through the elegant language of gravitational physics, we have seen how the unseen master of the outer dark shapes the very geometry of space. We have mapped a world 5 to 10 times more massive than our own, not with direct light, but through the beautiful, synchronized alignment of its distant companions. The math has revealed its presence, showing us that what appeared to be an empty, chaotic wilderness is actually a highly organized masterpiece of cosmic balance. In this deep understanding, the mind finds a sense of profound order and completeness, a realization that the universe is held together by invisible, enduring laws that never fail. As we linger here at the ultimate frontier of the sun's influence, the frenetic rhythm of the inner worlds completely fades away into absolute stillness. Out here, in the eternal twilight, where Planet 9 completes its slow, majestic 20,000-year loop, time behaves differently, stretching out into vast eons of peace. The freezing, dark blue clouds of this silent giant move in slow motion, untouched by the chaotic storms of warmer skies. The universe feels vast, protective, and incredibly serene, wrapping our stellar neighborhood in a blanket of profound quiet. We realize that the human mind, using nothing more than logic and wonder, can pierce the deepest shadows of creation to find harmony waiting in the dark. The ghost planet continues its silent dance, an eternal guardian at the edge of the void, perfectly balanced within the grand tapestry of the cosmos. It is time now to let go of the equations and the maps, allowing the analytical mind to rest after its long exploration. The structured beauty of the solar system remains secure, its moving paths synchronized in an unyielding, peaceful rhythm that will endure for billions of eons. As the distant needlepoint of our sun shines silently against the black canvas of the wider galaxy, we return from the frontier to the safety of our own quiet shores. Let your thoughts drift away like lonely ice worlds, fading gently into the calm, comforting dark of the night. Sleep soundly, knowing that the same elegant harmony that guides the grand architecture of the stars is watching over your rest, cradling the world in absolute silence.